Hey everyone, I know it's been a while. I hope you're all doing well. We're going to get back into things with a nice easy lesson, how to multiply powers. I'm going to show you how to do all that stuff you see in front of you on the screen in 10 minutes or less. Here we go. Alrighty, so for those of you who are following along with the online version of the textbook and want to read those examples as well, we are in Chapter 7, Section 1. The name of that section is Multiplication Properties of Exponents. Now, I told you this lesson was going to be all about multiplying powers. So let's review, what is a power? Well, a power is a term that has a base and an exponent. And the exponent is the little number here that tells you how many times to multiply the base by itself. Here the exponent is 2, so 3 to the second power means 3 times 3, which is 9. If we had 3 to the third power, now I'm going to write that base 3 times. 3 times 3 is 9, times 3 again, 27. And we can do this with any base and any exponent. 5 to the third power, for example, would be 5 times 5 times 5, which would equal 125. Now, we can do this with variables as well. Let's suppose we have x to the third power. How many times would I write x in a multiplication problem? 3 times. How do I know? Because the exponent is 3. See how they match up? X to the fifth power, we'd have 5 x's, and so forth. So when we talk about powers, these are what we're talking about. Okay, so now that we know what powers are, remember the whole point was to multiply powers. So the way you multiply powers when they have the same base is just to add the exponents. It really is as simple as that, just an addition problem. For example, let's say that I had a to the third times a to the fifth. Well, the bases are the same. I have a here and a here. So now I look at the exponents, 3 and 5. 3 plus 5 is 8, and we are done. It really is as simple as that. Well, why is it so simple? Why does this make sense? Why is this true? Well, let's take a look at what a to the third is. Just like up here, x to the third was x times x times x. A to the third would be a times a times a. And a to the fifth, well, that's going to be 5 a's. So a times a times a times a times a again. So here we have the 3 a's from here, we have the 5 a's from here. When we add these together, 1, 2, 3, 4, 5, 6, 7, 8, I have 8 a's multiplied in total. That's why this is a to the 8th. That's why we add them up. This number tells you how many a's you have in a multiplication problem. So with that explanation, I said that this is to multiply powers with the same base. So what about when you have a different base? For example, a to the third times b to the second. Well, let's write it out long ways like we did with the previous problem. A to the third, again, is a times a times a. I have 3 of them. That's what that exponent means. B to the second is b times b. Now, here's the thing. When I look at all these items that are being multiplied, how many a's are being multiplied? 3. And how many b's are being multiplied? 2. So here, notice that nothing could combine because these bases are different. If these were all a's, like in this example here, I could say, all right, there's 8 of them, a to the 8th. But because the bases are different, I can't say that I have 1, 2, 3, 4, 5. I can't say I have 5 a's or 5 b's. I have 3 a's and 2 b's in a multiplication problem. So that's as simplified as it can get. In other words, you can only add the exponents when the bases are the same. See the difference between these two examples? Okay, so the next part that we have to talk about, what about coefficients? Remember coefficients? Coefficients are the numbers that precede a variable. So for example, if I had something like 2x, it would be the 2, or 3x squared, it would be the 3. So When you have coefficients, you simply multiply the numbers just like normal. Let me give you a really broken down example. Let's say I have h to the second times h to the third. Do I have the same base? Yes. So what do I do with the exponents? That's right, you add them. 2 plus 3 is 5. Now, what if I just had the numbers 2 times 3? Well, that's easy, 6. Now, let's put it together. What if I had 2 h's to the second times 3 h's to the third? Well, when you have something like this, first multiply the coefficients. 2 times 3, that's 6. Now, look at the bases. They're the same, so you're right, we can add the exponents. So I'm gonna have h to the 2 plus 3 is 5. That's what you do with the coefficients. If you have negative, you still use the same rules for multiplying negative numbers. Let's say I had negative 2h to the second times positive 3h to the third. Negative 2 times positive 3, signs are different, so it's going to be negative 6. The bases here are the same, so I have h to the 2 plus 3 is 5. So negative 2h squared times positive 3h cubed would be negative 6h to the fifth. Okay, so now that we feel comfortable with that, let's try and get this as complex as we can. So let's look at this problem here. 4h cubed a squared times 2h a cubed. Well, first of all, let's take a look at the coefficients. I've got positive 4 times positive 2. 4 times 2 is 8. Now, let's take a look at the variables, and I've got a couple in the problem, that's fine. Let's start with the h here because that's the first one that comes up on the left. So here I have an h, and I have an h here as well. This is h to the third. If there's no exponent, well, how many h's do you think I have if there's no number there telling me anything? If you guessed 1, you're right. You can always fill in a 1 if there's no exponent there. 3 plus 1 is 4, so this is going to be h to the fourth. The next variable I have here is a to the second power. Here I have a cubed. 2 plus 3 is 5. So there we go. 8, h to the fourth, a to the fifth. Let's take a look at this one down here. So first let's look at the coefficients. Negative 2 and negative 3. Negative times negative is a positive. 2 times 3 is 6. I have an h here. Here I have an h as well. If there's no exponent, what is it? Glad you remembered. I'll fill in that 1. H to the fourth, h to the first. That's going to be h to the fifth. Let's take a look here. I have a to the fifth. I don't have any a's here at all. Does that mean it just goes away? No, it's still there, it still exists, it just didn't get any larger. There's nothing to multiply with. So we write it. I've got one other letter here. I have an x. If there's no exponent, that's right, put a 1 there. So x to the first. So looking at this example, you can see how when you have a variable here and there's not a match for it, there's no bases to multiply it with, it just stays the same. And here, we saw that if you didn't have an exponent, you can just add a 1 there. That's about as complex as it gets. Hope that was easy for you. We're going to do some practice on that, and we'll have a quiz at the end of the week. All right, everybody. Hope that was easy to follow. That was multiplying powers. If you liked the video, hit that like and sub button. If you didn't like that video, hit that like and sub button anyway. All right, have a good one. We'll see you next time.